Here we're given 3 different reactions and we're asked to determine, are they going to be spontaneous? And remember, spontaneous meaning we have a standard cell potential that is positive. So we're going to follow the same process with redox, and we're going to determine what's oxidation and what's reduction. So oxidation is going to be zinc there, and reduction is going to be, and yes, I realize I'm not putting the electrons on here. All right. So now oxidation occurs at the anode, reduction occurs at the cathode. Let's go to our table. Let's find zinc right here, negative 0.76. And nickel's a metal, it's probably gonna be down here. Here we go, negative 0.23. All right, so now I'm gonna write this big up here is gonna be E cathode minus anode. All right. So here, let's just plug and chug here. E cell energy, voltage of the cathode, negative 0.23 volts minus negative 0.76 volts. Now, some of you can probably identify this and use the shortcut that I talked about in the lecture, and if your cathode is above your anode, it's going to be spontaneous. I have to think about that really hard, so I don't use that. If that is you, that's awesome. I'm really happy for you. That's not me. So we get positive 0.53 volts. So the answer to the question is yes, it's spontaneous. Let's do the same thing. Here we have zinc is once again at oxidation. So the reduction is going to be calcium ion. Okay, so oxidation at the anode, reduction at the cathode. Find them on the table. Zinc, here negative 0.76, or you could have just copied that. Cathode, calcium down here, negative 2.76. Now somebody using the shortcut is going to go, your cathode is below your anode, so it's not going to work. If that's you, great. You don't have to show this work because it doesn't say what's the cell potential. So cathode, negative 2.76 minus negative 0.76. You can see here, we don't even need a calculator, negative 2.00. That is definitely not spontaneous. Negative voltage is not spontaneous. Here, let's identify oxidation. That's the loss. So that's going to be our iron going to iron plus 2. Be careful when you're dealing with the irons because it has multiple ions. So going to solid manganese. All right, oxidation occurs at the anode, reduction occurs at the cathode. Yes, I have to work these same way every single time. So make sure you're using the correct iron. So here's iron 3, which is not what we want. That's different than iron 2. So be careful here in matching up your iron. So part of the trick here is reading the table, negative 0.45. Let's see if we can figure out just from the position here whether we're going to have something that is going to be let's see here. Well, do I have a solid manganese? There it is. It's way down here. All right. -0 or -1.18. All right, somebody's going to go, oh, it's below, so it's not going to be spontaneous. You would probably be correct. Cathode, -1.18 minus -0.45. You can actually get the number, which is usually what I do. I can tell in my head that it's going to be still negative, but so this is not spontaneous.